In this HVAC training video, we're going over why this suction line is freezing on this outdoor air conditioning unit. It's not what you think, and you don't want to automatically think you're going to add refrigerant into the system in order to raise the pressure and raise the temperature on this suction line. So you got to take accurate measurements for the whole system. We've allowed this suction line to thaw out by turning this outdoor unit off while we let the indoor unit continue to run its fan motor. And so we're getting ready to connect our digital manifold set to this system. And so we're going to do the air purging process. And so you can see on a manifold set, usually you'll have handles here or valves here. We're in the off position. You're going to want to turn them to the on position. And we have a valve core removal tool here instead of a yellow service hose. And we've done that just to turn this valve to the off position. We're going to be during the air purging process where we are going to turn this red hose to the off position and we're going to connect in. And that's going to allow any air from here to flow through the manifold, out through the red hose and over to here. And that's how we're going to get rid of the air in the hoses so we don't accidentally contaminate the system. So now, since these are both on, we can purge the air out. Now all the air is out of both hoses and the manifold, and we can go ahead and connect our red hose in here. We can turn this valve to the on position. We're also going to turn these off. So if this system was running, after you purge the air out here, you're going to want to turn these off because you don't want accidentally to have subcooled liquid traveling through this hose over to the manifold and back this way into the suction line, because that would end up slugging the compressor. But this system is off right now, and so our manifold's off. And so now we're going to go ahead and connect our temperature meters. We can take some steel wool in order to just clean off the part of the tubing where we're going to be measuring the temperature at. So remember, we need pressure to convert it to saturated temperature, which right there is the liquid sat temp, vapor sat temp. And then we need our line temperature as well. So this is our blue one. This is going to connect onto our large low pressure side. And this one right here is our red. And so we're going to take our red, we're going to turn that on. See if you can go ahead and see the display. Right now it says 82 degrees. We're going to go ahead and connect that on right here onto the line. And so that will wirelessly connect over to here. You can see that there. And then we're going to turn this one on. Inside, there's a thermistor right here in order to measure the temperature. Now we can go ahead and turn the system on, and we're going to monitor both the pressure, which is right here, 214.5 psi. We have R410A selected because this is an R410A system. This system has a thermostatic expansion valve on the indoor unit. And right over here, you're going to see the pressure converted to saturated temperature. So the saturated temperature of the refrigerant in the tubes right now is 73.7 degrees. You can see it on both sides. And so let's go ahead and turn this system on and see what happens over on the suction side. Now we're going to turn the unit on at the outdoor disconnect. We're going to give it a little bit of time. You want to wait about 5 to 10 minutes before measuring the refrigerant charge or doing troubleshooting with the refrigerant charge measurements in order for the refrigerant to cycle through the system. You're noticing our vapor saturated temperature is continuing to lower. So our pressure is lowering, which means our saturated temperature is lowering. But we want to give it, say, 5 to 10 minutes before accurately measuring these pressures and temperatures. So now you can see that the pressure after about 7 minutes has lowered all the way down to 95 psi for R410A at the indoor coil, and the saturated temperature is now below 32 degrees. And so any humidity in the air crossing that indoor coil is going to freeze onto that coil, and so that's a problem. And so you can see over here our pressure, 268 psi. We convert that to the saturated temperature of R410A in the middle of this outdoor coil, and we're left with 87.9 or 88 degrees. So you got 88 minus 80.6, and you have 7.7 degrees of subcooling. Up on the rating plate, this unit is calling for 8 degrees of subcooling, so we're very close in the subcooling, which means that the refrigerant charge is most likely correct because we have a thermostatic expansion valve at that indoor coil. Now, as far as the vapor line goes, we have a very low saturated temperature, which means that we have a low heat load at the indoor coil. So that means either we have low airflow or basically the temperature inside the building is very low. But before you check the refrigerant charge on a system, you want to make sure that it's above at least 70 degrees inside and 70 degrees outside as a dry bulb temperature. So inside we have about 61 degrees as a indoor wet bulb temperature and 70 degrees as a dry bulb temperature. So we know that the indoor temperature is not the problem, it's the airflow. And so eventually what's going to happen is if we keep letting this thing run, this line is going to freeze. Right now you see it's right at about 49 degrees on this line, but the saturated temperature is 28 degrees. It's continuing to lower. And so that's why this is freezing. So we don't want to just dump refrigerant into this system in order to try to increase the pressure over here, because that's not going to work. This system has a thermostatic expansion valve. It's not going to allow more refrigerant into that indoor coil because we put more refrigerant into the system. The only thing that would happen if we added refrigerant is this pressure is going to increase and the subcooling is going to increase. That's it. It's going to become basically less efficient because we have more liquid stacked in the outdoor unit and less of a phase change area in the outdoor unit. We have to measure airflow before doing this. Before measuring the refrigerant charge, you have to measure airflow. So of course, I chose to do this backwards just to show you in this video. In other videos, you can see how to measure the airflow, and I'll actually show you what our CFM measurement is in the inside of the building here. But you can determine why this suction line is frozen with your refrigerant indicators here. So you can tell if this is frozen, it's either one of three things. It's either low refrigerant charge, a liquid line restriction like a clogged filter dryer, a bad TXV like it's clogged, or something like that, or you have low airflow. A lot of times you have low airflow as the problem. We have to be able to adjust the airflow or find out if there's a clog in the ductwork, like the ductwork fell apart, the ductwork's undersized, maybe it's just as simple as a clogged filter. So it's airflow before charging. Always measure the airflow because that has to do with the energy transfer of the system, just as much as the refrigerant charge. What I'm going to do at this point is I'm going to pull this outdoor disconnect in order to shut this outdoor unit off. I'm going to allow the indoor coil to thaw out, and then we're going to be measuring the airflow at the indoor unit. Here we have our indoor air handler. This is the return, and just to give you a couple of reference points here, it's about 71 degrees as a dry bulb temperature inside the building. It's about 62 degrees as the indoor wet bulb temperature as far as the amount of humidity in the air. And so we're going to be measuring the airflow with our TEC TrueFlow grid, and so we're going to be using our app, and as well we're going to be using our manometer here. So we're going to turn this on. Turn this on. We're going to go to our app. So here on the side of the app, you have air filter location. We're going to click filter drill right here. So the filter drill is right on the back of the unit back here. And so cooling capacity is actually 3 tons. So at the outdoor unit, it says 36,000 BTUs of heat removal capacity. So we have 3 tons right there. The return air temperature is about 70 degrees. We're looking for about 400 CFMs per ton, and the reason for that is right here we don't have a crazy humid climate where we would want to maybe lower it down to 350 CFMs per ton. We're also not in a very dry climate where you might want to have 450 CFMs per ton. We're at about average, so we're looking for 400 CFMs per ton, so we're looking for about 1,200 CFMs. And so let's go ahead and click next. It says close any humidifier dampers. We're going to go ahead and take our measurements. So we're going to put this static pressure tip in the supply duct. So we have a very low static pressure right now. So our static pressure is about 0.027. And so the reason for that is there's no obstruction in the supply duct itself. So this is just our little test air handler unit in our shop. We're going to go ahead and take our measurement right here. So we're doing that with the filter in the filter return air grill in the back. And so that filter is clean, by the way. It's a pleated 1-inch filter. So then we're going to hit continue, and then we're going to switch it out with the TrueFlow grid. Now we're going to click take measurement. So you just want to make sure that you have the TrueFlow grid facing in the correct direction. Of course, the back here is just an open hole where we're located at. And so you can see our CFMs is extremely low. So the cubic feet per minute that we have is 520. It needs to be 1200 CFMs. That's how bad of airflow we have. So we want to find the airflow problem. So, you know, do we have an issue in the return or in the supply? And with this app, you can determine where the problem is. I already know where that is, and that's with the airflow settings in this air handler. So we're going to go up to the electrical cabinet and make our adjustments, and then we're going to measure our airflow again. Want to make sure to turn the power off to your unit. We're going to remove our cover. And then we have our airflow selection right here. So as you can see right here, the size, we are actually at a 36. So we're going to move this from the 24 to the 36. System type, this is AC, so we're just going to move this over to AC right there. So you can see that. I don't know if you can see that or not. AC. Then we're going to move the CFM adjust to nominal instead of low or normal. And the on-off delay, that doesn't have to do with this CFM issue. And the continuous fan, that's only if you just are powering the G terminal right here. But during air conditioning mode, we're actually powering the Y. And so anytime the Y is powered, you're going to also be most likely powering the G as well on a circuit board like this, based on the thermostat that you have. But that's going to turn on the outdoor compressor and the indoor fan motor. And so it'll turn it on at its higher fan speed when you have 24 volts on the Y terminal. So we're going to go ahead and put this cover back on, and we're going to check the CFM again. So now we put the top cover plate back on the unit, and we're going to turn the power back on, and we're going to measure our inches of water column in the supply with our app. So we're just filling out this information again. And you can see our static pressure is 0.13 with our static pressure tip. That's inserted right in the supply plenum. And so we're going to take our measurement. And so this is showing in the air handler right above the electric strip heating. This one doesn't have any electric strip heating in it. And we put our hole right in the plenum, which you can always put a cap in there, a duct plug, after you're done. Okay, so continue. Now we're going to switch out our filter with our TrueFlow grid. We're going to take our measurement now. So this static pressure measurement is a reference point in order to be able to measure our CFMs through this app. And so continue. We can save this. And it's saying that our airflow is 392 CFMs per ton. So we have 1,175 CFMs for our 3 tons. And so we are good. So if anything, we're just slightly low. I mean, we're right on there, right on 400 CFMs. Since our airflow is good, what I'm going to do is I'm going to turn the power off to this air handler. I'm going to put back in the filter, and then I'm going to turn both this air handler on and the outdoor unit. I'm going to wait about 5 to 7 minutes before measuring our pressure, saturated temperature, superheat, and subcooling. Now we're going to turn the outdoor unit back on. Let's give it about 7 minutes or so. So anywhere between 5 to 10 minutes, and then we'll check our pressure, saturated temperature, superheat, and subcooling. So it's been about 7 minutes, and you can see our vapor pressure over here is about 120 psi, 119.9. We convert that to a saturated temperature at the indoor coil of 40.4 degrees. So that is about normal for a saturated temperature that's controlled by a thermostatic expansion valve. Now our suction line temperature over here is 57 degrees, and so you take 57 minus 40, roughly, you have 56.8 minus 40.4, and you're left with a superheat of 16.4. So that's the total superheat when we measure it out here, because we're not measuring it at the indoor coil. So that's pretty normal, it's just a little bit high. And if we measure on our high side, it's 267 psi. We convert that to a saturated temperature for R410A in the outdoor coil, it's 87.9. We also have a line temperature right here of 80.9. So we take 87.9 minus 80.9, and we're left with a subcooling of 7.2 degrees. Up on the rating plate, it says the target subcooling is 8 degrees. So we're very close to the target. We're just a little low, but the refrigerant in this system was not the problem. As you can see here, it was that we had low airflow. So you can tell there really is no issue with this system right here. We could add a little bit of refrigerant, that's about it. But there is no other problems. It's not a liquid line restriction or anything like that. So you always want to measure airflow first before trying to measure the refrigerant charge. But even if you do, there are some indicators to try to tell you what's going on. And so we have indicators in our troubleshooting cards right here, which are available at acservicetech and at amazon.com/shop/acservicetech. But the reality of it is, no matter what air conditioning or heat pump system you're working on, you're going to want to target that 400 CFMs per ton before you even get started. And I have a bunch of other videos linked down in the description section below on measuring airflow first. Let's go ahead and disconnect our manifold from this system. So in order to do that, what we're going to do is we're just going to shut this valve right here, unscrew this, and basically we're going to be charging the liquid that's in this hose back into the vapor side. And so we're going to do that a little bit at a time. So since we have this valve down here on the middle part right here in the closed position, we're just going to go ahead and open up our liquid side. So you can see that that valve right there is in the closed position, so we're safe right there. Let's go ahead and basically put this liquid right over into the side, and then we can charge a little bit at a time into the low side of the system. We don't want to steal refrigerant from this unit. You can see your liquid flashing right here in the sight glass. There's liquid refrigerant and oil there. We're going to want to do this until basically the pressure over here matches the same size, the same pressure as over here. And so we're good. So after that, we can go ahead and disconnect our clamp. I'm going to shut this ball valve off right there, disconnect right here. And then all you have left is just a little bit of vapor in the manifold and hoses, which falls under the de minimis rule. So that's it. That's all it is. It's not much at all. And we're going to go ahead and shut these valves again, and we can leak check over here at the ports. To leak check, what we're going to do is we're going to put one of these little test caps on the ports, and we're going to use our big blue leak detector. We're going to make sure that after we put this test cap on, after we add bubble leak detector, that there is no bubbles. So that one's good. We can go ahead and put our locking caps on. So no bubbles are forming there, so we're good there. So that's it. So just remember, as far as indicators go, you can have a low side saturated temperature and also a high superheat and a low subcooling. That would indicate that you have a low refrigerant charge, but low airflow is a low sat temp, average total superheat, and then also on the liquid line, you're gonna have a normal subcooling. And so a liquid line restriction differs from low airflow because it'll have an extremely high superheat where the vapor line temperature will be about the same as what's inside the building. So that will be as high as, like, say 70 degrees. In this case, we had a vapor saturated temperature that was right around, say, right around 50 degrees or something like that. And so if you are looking for the indicators to determine what the problem is when you're troubleshooting, make sure to check out our quick reference cards, which are available over at acservicetech.com and also on Amazon. We also have our refrigerant charging and service procedures for air conditioning book. So this goes over all the troubleshooting indicators. It goes over how to work with refrigerants on, say, single stage and two-stage systems, how to check superheat, subcooling, all the different troubleshooting indicators. And so it goes over measuring airflow and vacuum procedures, recovery, and a lot more. We also have our mini split book, so for those that are not normally working on mini splits or want to know how to troubleshoot mini split systems along with multi-zone systems, make sure to check out our inverter mini split operation and service procedures book. So both of these books are available over on Amazon and also at our website at acservicetech.com, and hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.